This is a handout that I'm giving you on the difference of two squares because I think we need to review this pattern and a perfect square pattern before we move on to grouping, especially because some of you are mixing up these two patterns. So let me go through some of the problems on the handout just to remind you how they work. I'm gonna do 10 and 11 on the first side. Now, notice here that each of these polynomials has two terms, and each of the terms has a square root, a nice square root. That means they're perfect squares. So this is really the difference between two squares. Difference means subtraction. So I'm gonna put 2 here, right? 2 squares. Now, if you have the difference of two squares, it fits into a pattern, it factors into 2 parentheses. Now, we're assuming here that there's no greatest common factor. You always want to look for that first, but in these 12 problems, these initial 12 problems, there is no greatest common factor. But you should be looking for them all the time. Anyway, it's going to factor into 2 parentheses. One has a plus, one has a minus. I'm going to write the square roots under each one, just so I put the right thing in the parenthesis. The square root is 3, the square root is 4x. You don't have to put them squared. You don't have to check a middle term because there isn't any. This is not a perfect square test. This is just writing the 2 square roots. So you factor it as 4x plus 3, 4x minus 3. On number 11, this is also the difference between 2 squares. His square root is 11, x squared square root is x. 2 parentheses, one's plus, one's minus. It doesn't matter if you put the minus in the, like you could switch the order of the parentheses. You could have the minus first and the plus second, that's okay. X plus 11, x minus 11. All right, so you'll do the rest of those in the first group. Now the second group says factor out a GCF if necessary, then determine if this is a difference of, I say 2, they are perfect, the difference of 2 squares, and then factor accordingly. So a lot of these are going to have GCFs. I will do, let's see on the back side, I'm going to do 24 through 27. Now, step 1 when you factor is always to look for a greatest common factor. And if there is one, you want to pull it out. The greatest common factor is the largest factor that is in each piece. It has to be in both of them. So at first when I looked at these, I saw that there's a 5. 5 goes into 15, 5 goes into 30. That is a common factor, but it's not the greatest common factor. 15 goes into itself. 15 also goes into 30 evenly. That is the greatest common factor. So I need to first factor out a 15. You shouldn't have an x here because x is not a common factor. There's no x in both of them. So when I pull out the 15, what I get is x squared, because 15 times what gives me 15x squared? X squared. Plus, because that's a plus, 15 times what gives me 32. That's the GCF step. That was my chinchilla. I don't know if you heard that, but he was squeaking. All right, second step, look for a special pattern. Well, what's left in this parenthesis? First of all, there's no minus sign, so it can't be the difference between 2 squares. The other problem is 2 doesn't have a nice square root. So this doesn't factor any farther. That would be the answer. You only want to say prime if you can't factor anything at all, not even a GCF. Okay, number 25. There's a greatest common factor of 3. So I need to first pull out the 3. 3 times what gives me 3x squared, which is x squared. 3 times what gives me 9, put the minus there. 3. Okay, now looking at this, this is not the difference of two squares. It is a difference because it's a minus. X squared is a square, but 3 doesn't have a square root. So this doesn't break down any farther. This would be the answer. It's just a GCF. Okay, number 26. I know that 3 goes into both of these terms because if you think money, 3/4 makes 75 cents. So there's a GCF of 3. 3 times what gives me 3x squared? That will be x squared. Minus, because it's minus. 3 times what gives me 75? Quarter, 25. Now I'm looking at this carefully. I do have a difference. That is a perfect square, that is a perfect square. So what's left in this parenthesis is a special pattern. It's the difference between two squares. That means it's going to break into two pieces. So you want to bring the 3 down. That is one factor. Then the square root of x squared is x. The square root of 25 is 5. 1 is plus, 1 is minus. It's just like the ones I did on the other side, except you have a 3 in the front. You had to first pull out a GCF. X plus 5, x minus 5. So there's 3 factors in this answer. All right, and then on the last one, 27, 14 is the greatest common factor, so I'm going to pull it out first. 14 times what gives me 14x squared? X squared minus minus. 14 times what gives me 14? 1. Okay, that will break into two pieces. So the square root of x squared is x. You might not think about it, but the square root of 1 is 1 because 1 times 1 is 1. So this is the difference of two squares. So it's going to break into two pieces. One's a plus, one's a minus. X plus 1, x minus 1. Don't drop the 14 because that has to be part of your answer. All right, so you're going to do the rest of the problems that I didn't do using these as examples.